Let me provide you with three different types of intuition for why the first and second order conditions look like they do. Let's start with a graphical intuition of the first order conditions. Suppose that you have a function that looks more or less like this. That is the objective function that we are trying to maximize. Remember that the first order condition states that at any local maximum, the derivative at the optimum, at the local maximum, has to be equal to 0. Now, to see why this has to be the case, consider a point, for example, like x, at which the derivative clearly is not equal to 0. In this particular case, it's positive. It is easy to see that the value of the function at that point cannot be a maximum. In other words, x cannot be maximizing the function because given that the slope is positive, if you move a little bit to the right, let's say to a point like x plus delta x, you can increase the value of the function approximately by the value of the slope times delta x. Now, it's also easy to see that if you're at a point like x hat, at which, in this case, the value of the slope is negative, you can also not be maximizing, because if you move to a point like x hat minus dx minus delta x, you can also increase the value of the function for similar reasons. Now, it's very easy to see that the only point at which you cannot play this trick of improving the value of the objective function by changing the value of x is a point like x star at which the slope is 0. Because if you move locally either to the left or to the right, the value of the objective function would not change. This provides an intuition for why the first order conditions have to satisfy this property at a local maximum.